So guys, today I'm going to present or going to do one automatic night light circuits, and this is basically it is used for the automatic night light you want to do at home. Basically, you want to do something unique project in your college, then it is good for you. And today I'm going to present this project on the Proteus. Basically, why we use Proteus? Proteus is basically it is good for this implementations. We do not buy directly the components in markets, and first we will check to how this project is working or not. We use component is good or not, and then we do this project. Okay. So Proteus is good for the implementations, and that's why I'm using this Proteus software. Basically, this Proteus software, how it works. Now I'm starting this project. Okay, go to the file and then new project. Yeah, give the name to the your project. I'm giving auto. Okay, and then next. You want the any schematic design, you can, but I don't want. And then you want the PCB layout, then you can, but I don't want the PCB layout also. Then you want to use controller and something or Arduino, then you can create a one form project. Okay, but I don't want. Then I'm going doing next and then finish. Okay. Then go to the ISIS. This is basically the front window of the Proteus. And now we will start one project. This automatic night lights. And for automatic night lights, they will be required for a few components. Then how we select the components? Go to the P. This is the component list basically, and which component you want. Then it search it. First, I want the resistor. Resistor is the most important. Basically, this is called as American resistors. The symbol is called American resistor. Then double click it. Then come in your component list. Okay. Then cut it again, and then second one we want LDR, light dependent resistor. Is most common for this automatic night lights because it is good for automation purpose. I'm using the torch with and light because it is good to calibrate. Okay, then double click it. Then I want one op-amp. This is I'm using the competitor op-amp LM358. This is a dual op-amp basically. Double click it. Then you come in your component list. Uh, then I want one pot. Pot is for the accuracy purpose. When I'm using the pot, this give the perfect output. That's why I'm using pot. I'm using, let's see, I'm searching which I want, which, this one, this variable potentiometer. Okay, double click it in your component list. Then we want one transistors. Transistor is basically used for do not enter 10 transistors. Enter the specific transistor name BC548. This BC548 is used for the amplification purpose. When op-amp do not give this maximum output, then we want to amplify the voltage. That's why we use the BC548. Okay. Now, second one is relay. Relay is also most important. Then use the animation relays. Then you can see the switching of the relay. Then I'm using this relay. And take one lamp. Lamp is also very important. Then take the animated light lamp. Okay, that's it. Then click OK. Uh, then now, first take the op-amp. PC. Take one op-amp LM358. Okay, this is one op-amp. You can see this. This is called as a dual op-amp. This is LM358, and why we use dual op-amp? Sometimes we want to do this want to control the two three lights, then this IC can help us to control the two lights. Okay, that's why I'm using the LM358. Okay, but now basically I'm show you the one only. Okay, then take your resistors, click on it and take rotation. Go to this for the center purpose. Okay, uh, okay. Then click right click on rotate it, and then use second one resistors for this output purpose, and then take one uh, take put pot, rotate it. Okay. Then we want one LDR, torch LDR. Okay. It is more important. That's it. Hmm. Then we want the BC548 for outputs I said as per the amplification purpose. Then take relay. Relay is also important. Relay, okay. And one lamp. That's it. Yes. So now connection. Yeah, that's it. This connect to this LDR, and then connect input of the op-amp terminal number 3 to the mid of your voltage and LDR and resistors. Okay, and second terminal is connected to the port variable connector. Okay, then connect this directly to this LDR, okay, and then connect this terminal to with 12 volt batteries. Okay, now we want one battery. Basically, this battery is 12 volts. Okay, so I'm going in component list and I'm taking one battery. Okay, there's double click it and okay, take one battery for the take battery, place it and connect to this opposite to the LDR, opposite to this divider, and this connected to the okay, and connect to this ground. Okay, now you want the ground. Okay, then where it is ground? Ground is there. This is a ground. Connect this to the ground. Then connect this ground to the emitter terminal, and this terminal 8 is connected to the ground and 4 is connected to the 12. Basically this is a VREVRF, and then output one terminal is connected to the resistors 10K pot and then connected to the BC548 base terminal. Now we want to change this resistance of this resistor. Basically I'm using 22K. Now we'll connect this terminal to the relay. Now sometimes this relay get produce the back current, and that's why we want to use one diode. This is component list. Where is it? Yes, go to this and P, go to the component list and diode. Okay, sign. Yes, that's it. This is your supply, AC supply for the lamp purpose. I'm taking lamp upward side. Okay. Go to the upward side and then supply Okay, now relay connections. Relay connection basically is a non-normally open connection, normally open connected to LAN, and then LAN connected to the supply, and then supply connected to your common terminal. Okay, that's it. This is a basic diagram of or basic circuit of the LDR using automatic night light using LDR. I'm here use 12 volt battery, then change the voltage. This is 12 volts basically. Okay, click OK. Then any changes? This is the basically full circuit. You can see this. First, what we can use is first we use 12 volt battery, then LDR with lamp, then 22k volt, 22 volt resistor, ohm resistor, and then the one pot for the efficiency purpose, and then one op-amp LM35. This is basically the dual op-amp, uh, and then we can use one resistors, 10k resistors, and then transistors. Transistor is used for basically this amplification purpose, and this transistor collector terminals goes to this relay, and as parallel to the relay, we connect the diode. Why diode we can use? Diode basically we use for the back current for protect the relay. That's why we use the diodes. Okay. Then and the other sides of the relay we connect the normally open terminal is connected to the lamp, and then lamp connected to the sine wave voltage 230 volts. Basically we use a 12 volt battery, 12 volt lamp, and that's why load is 12 volts. That's why we use the sine wave voltage, and the setting of this voltage is firstly we set the amplitude in 12 volts, 12, and its frequency is 5 volts. This basically is for the 12 volt loads. As you want to increase the load, you can change as per the specification. Okay. So that's it. This is the basically the final circuit, and now go to the simulation. First save it, and then go to the simulation on the left corner. See the simulation, and then click on it, and then your circuit gets started. Okay. And then what is the system of this automatic night lights? When the light will get on this LDR, then your lamp is not blue, and then the darkness is come, then your light is blue. But when this light is get more on this LDR, then your LDR gets relays get off, and this lamp is turned off. So what is basically the working of the LDR is when this light fell onto this LDR, then this resistance get increased, and this divider we use this divider for this divider to control this voltage. Then we get this minimum voltage on this relay side, and relays get off. Relays goes in off state. Okay, and that's why the relays goes in off state, and the relays normally close terminal, or relays goes to the close terminal, and lamp get off. Okay, then we want to see the voltage. Basically, then voltmeter. Basically, this is a DC. We are connected to the battery. Then the DC voltmeter. Get this DC voltmeter. Place it here. DC voltmeter, and connect this voltage. Connect positive terminal to your relay, and negative terminal of the voltmeter connected to the negative terminal of the ground. Okay. Then simulate it. When we will see this relays goes in this off terminal. Okay. That because this voltage is so much increased, it is approx 12 volt. That's why this relay is going off terminal, off state, because relay is a 5 volt relay, and they do not sustain this that much current. That's why relay is in off state. When you will see, then when we decrease the lamp, means decrease the sunlight. When we decrease the sunlight and this blackout will come, then relays goes in this off, relays goes in on state, and that time your current is 1.42 volts. That's it. That's why this relay is working like that. Um, okay, then stop this simulation and connect this to just cut this, delete it, and connect to this terminal. Okay, and then simulate. Then we see this voltage is approx 0.87 volts, and then we increase the intensity or increase the sunlight on LDR. Then the see the voltage is decreasing gradually, and we darkness will come. Then voltage is increasing 0.8. Okay, that's it. And what is the op-amp? Op-amp voltage. Op-amp voltage is basically approx. Op-amp voltage is basically approx 10 volts. Okay, and that's why we use 10k resistors, and 10k resistor get dropping this voltage, and we will get this 0.8 or 0.9 volts. You can see the here. Okay, uh, then stop the simulation, delete it. Okay, and connect here, delete and connect this to the amplifier. Okay, then let's turn on the simulation. I can see this voltage is 1.42 volts, 42 volts, and because this directed 12 volts connected to the your relay. Okay, when the light will come, then your voltage is 12 volts and is amplified, and this relay gate in off state. You can see here relays gate goes in off state. That's it, guys. This is a small project. Basically, we used for this automatic night light. We can use at home also. You can design one circuit for your home for automation purpose, for balcony and something else. That's it, guys. This is my first project, and please, guys, do like, share, and subscribe for my channel. I will come back with this new innovative projects on Proteus, and please support me for this for channels so you can understand more about the electronics and what electronic works, which component is good for your project, and something else. That's it, guys. Bye. Thank you for watching this video. Bye bye.